9.3, rotations. Rotation is a turn of a figure about a center point. This is our next type of isometry that we're going to cover. Remember, an isometry is a transformation where the pre-image and the image are congruent to each other. So for a rotation, you always need three pieces of information. You need the center of rotation, the point where you are rotating about, the angle of rotation, which we are going to use as a positive number of degrees for how far you are being rotated, and the direction. So now the direction could be either clockwise or counterclockwise. We are always going to use counterclockwise rotations unless we are told otherwise or unless it's otherwise stated. So our rules for rotating, if we have this diagram over here, we're going to use point R as our center of rotation, and then X degrees will be the angle of rotation. So anytime you rotate, the center of rotation is itself. The pre-image is the center. The image would also be the center. So anytime you rotate, the center point does not move. That's the big key there. And then a point that's not at the center of rotation, you would have that point, if you connected the pre-image point and the image point, so the image is this point up here, here's V prime. What this first part tells us is that point never gets any closer or further away from the center of rotation. It stays the same distance from the center of rotation. And the measure of the angle at the center of rotation, so this central angle here, is that angle of rotation, how many degrees you are rotating. Now, since that's a central angle, it is the same as the measure of the arc. So out here we have shown the arc that the point would travel along if you could show that. So here we have a regular pentagon divided into 5 congruent triangles. We have 3 problems here that we need to find the image of a certain point when we're given the angle of rotation. So what we have to do before we really want to start any of these is we need to find the measure of a central angle. Now, since this is a regular pentagon, we know that the measure of all these central angles are all going to be congruent. So in order to find one of those central angles, we know there's 360 degrees around that center point. It's being divided into 5 equal size angles. So 360 divided by 5 would give us 72 degrees. This is our central angle. So now it says that we're going to take point E and rotate it 72 degrees about X. It doesn't say anything about direction, so this is automatically a clockwise rotation. So if I take E and I rotate it through 72 degrees, which is just one central angle, that E would travel along this arc, which is also 72 degrees, and the image would be the original point P. For part B, we have to find the image of point P if we rotate it 260 degrees about X. So now we need to take 216, we need to divide that by 72 so we know how many central angles we are rotating through. So we have 3 central angles that we'll be rotating through. So if I take P, rotate it through 3 central angles, there's 1, there's 2, there's 3. The image will be N. Finally, if I take T and rotate it 144 degrees about point X, I need to do the same type of thing I just did in B. I need to figure out how many central angles I'm rotating through. So 144 divided by 72 is 2. So if I take T and rotate it through 2 central angles, it will end up at point E. So E is the image. Here's another shape that we have. We need to find how many degrees are in the angle of rotation that takes, about point C. So C is your center of rotation, and it takes Q all the way around to X. So we really want to know, and it doesn't say anything about direction again, so this is counterclockwise. How many degrees to take Q counterclockwise all the way around to X? So what we need to do is we need to actually take this shape and we need to divide it up into however many central angles we would have. So using these diameters, since this is a circular shape, if we draw these diameters through this shape that would cut it exactly in half, we can start to see how many central angles we have. So this isn't perfect, but hopefully you see the general idea. So this tells us we have 1, 2, 3, 4, 5, 6, 7, 8 central angles. So we have 360, again, divided by 8. This is going to give us 45 degrees central angle. How many central angles do we have to rotate through? 1, 2, 3, 4, 5. So now if we take 45 and multiply it by 5 central angles, we have 225 degrees. That is our angle of rotation. Same kind of idea in number 5. So we're rotating about C again. Now we want to take Q and map it to M. So Q is the pre-image, M is the image. So we already know we have a 45-degree central angle. Now we see that there's only 3 central angles being used. So again, we have 135 degrees when we multiply those together. So if you take a shape, a kite in this case, and rotate it 30 degrees, and then take that new shape that's already been rotated and rotate another 60 degrees, both around the same center point, what single rotation is actually being made? You're actually making a 90-degree rotation about that center point, just like with other, this should say composition. Apparently I locked it. It's a composition of rotations. Just like with translations, you have a composition of rotations. So some more examples. Here we've got a regular hexagon. We know that it divides the hexagon into 6 equilateral triangles when we draw in all the diagonals. We need to find the image of point B if we rotate 240 degrees about M. So again, we have to find a central angle. So 360 divided by 6 tells us that one central angle is 60 degrees. They're all the same because it's a regular polygon. If we're going to take 240-degree rotation, figure out how many central angles we have to rotate through. There's 4 of them. So we want to take B and rotate through 4 central angles. So there's 1, 2, 3, and 4. So our image is point D. Now B is where it starts to get more difficult, because now if you notice, we're changing the center of rotation. We want to rotate about point F. This is now our center point. That is the point that is no longer going to be moving. So now our central angles are not at point M anymore. Our central angles are at F. So we know this central angle at point M is 60 degrees. We need to figure out what this central angle is at F, and it's going to be the same for all of them because it's a regular polygon. So first thing we need to do is find that angle, find the measure of angle AFM. Well, if this is a regular hexagon, we know that AM and FM would be congruent to each other. So then we would be able to take the fact that we know a triangle adds up to 180. And since it's now an isosceles triangle, we can subtract the 60 and then divide by 2. This would give us 60 degrees. And that is the measure of angle AFM. So now if we're going to rotate 60 degrees counterclockwise, because it does not say clockwise, about point F, that would take M and rotate it one central angle around point F. So our image would be point A. We attempt number 8. We have now a 12-sided polygon. So if we were to just connect all the points of the squares, we would have a dodecagon, 12-sided polygon. So find the angle of rotation that takes W and maps it to B. So W is the preimage, B is the image, using M as your center of rotation. So we know since it would make a 12-sided polygon or a dodecagon, to find a central angle, we would divide 360 by 12. That gives us 30 degrees. Now, if you count how many central angles there would be, there'd be 1, 2, 3, 4, 5, 6, 7. You have 7 central angles that you have to rotate through to get from W to B, so your angle of rotation would be 210 degrees. All right, here we have a composition of rotations. If you have a 145-degree rotation, then a 250-degree rotation. To find the result of those two rotations, you simply add them together, make it a single rotation of 360 degrees. Describe the image. Don't say it's the same as the preimage because it's an isometry. That's always going to be the case. You can say the image is the preimage. It appears that nothing has been changed. Now I'd like you to try to come up with as many rotations as you can that would take point C and map it to point E using this picture. I'll give you a hint that there's 3 of them that would work. I want you to try to find all 3. Those are, actually I should say this, there's 3 of them using just counterclockwise rotations. Keep in mind there's also the ability to rotate clockwise. See how many of those you can find. So here are all of the counterclockwise rotations that you could use to map point C to point E. So you're going to need to write these down. The first one, if you simply use point Q as your center of rotation, and you rotate point C 180 degrees. So I can do this. If I rotate 180 degrees and point Q, if that's the center of rotation, that means it has not moved. If I line that up again, you can see that point C and point E end up in the same spot right here. So the first rotation, the easiest one for most people to typically find, is a 180-degree rotation about point Q. The second, now we start moving our center of rotation. Let's say we use point B as our center of rotation this time. So point B is the one that's not going to move. If we rotate just 90 degrees clockwise, so rotate this 90 degrees clockwise and move it so that point B has not changed at all, you can notice if these would line up perfectly. There we go. You can notice that point C and point E end up in the same spot. So that again was a 90-degree rotation about point B. Finally, if I use point D as the center of rotation, and I take and I rotate this 270 degrees, and I put point D back here so that point D hadn't moved, C and E are in the same spot again. So that was a 270 degree rotation about point D. So now keep in mind, there's all of the counterclockwise rotations as well. Plus, you can use rotations where you end up rotating more than 360 degrees. So there's actually an infinite number of answers for a problem like number 10 here. So at this point, if you have any questions or aren't clear on anything, feel free to go back in the video and rewatch anything. Otherwise, here's your assignment.